Hello everyone! Today our group for New in 10 will present about quantum world. And this is the table of content, which the first one is the definition and theory of quantum. The second one, chemistry behind the quantum behavior. And last is application.
What is quantum? Quantum is the smallest amount or unit of any physical property such as energy or matter. Quantum theory is a more physics-theoretical basis that helps explain the behavior or nature of energy and matter.
So first, let's talk about Maxwell's electromagnetic wave. In his conceptualities of electromagnetism, Maxwell characterized light as a propagating wave of electric and magnetic field. As you can see in the picture, there is magnetic field and electric field in the light form. Next, more commonly, he predicted the presence of electromagnetic radiation, coupled electric and magnetic field, drawing a wave at a speed equivalent to a known speed of light, which speed of light is equal to 3 times 10 to the power by 8. Next, we will talk about Maxwell equation of electromagnetism. So Maxwell equation contain 4 equations that describe the behavior of electric and magnetic field and how they are associated with each other. They demonstrate that electric and magnetic field are a two exemplification of the identical phenomenon. So the first equation is Gauss law of electricity, which is divergent operators times by electric displacement is equal to free electric charge density. The second one, Gauss law of magnetism, which is divergent operators times by magnetic flux density is equal to 0. Next, for the law of induction, which is current operators times by electric field, chain of magnetic flux density over by rate of change of time. Next is Ampere law, which is co-operators times by magnetic field is equal to the free current density plus by rate of change of electric displacement over by rate of change of time.
And next is Planck quantum theory. So when the solids are heated, they emit a variety of radiation with a wide range of wavelength. For instance, when the solid is heated, not only does the temperature increase, but the color also changes from the region of a lower frequency to the higher frequency or red to blue, as you can see from the picture. An ideal physical body that emits or absorbs all the frequency radiation is called the blackbody, which absorbs all the light color and no light can be passed or be reflected from it. The emitted light of blackbody is called blackbody radiation. The frequency variation for blackbody radiation is depending on the temperature. At the temperature, the radiation intensity increases with wavelength, but it will increase to the maximum value and then decrease while the wavelength still increasing. Therefore, Planck quantum theory was able to explain the phenomenon of blackbody radiation that is not continuous rise. So according to Planck quantum theory, different atoms and molecules can only emit or absorb discrete amount of energy, and the smallest amount of energy that can be emitted or absorbed in the form of electromagnetic radiation is known as quantum. And the radiation energy emitted or absorbed is directly proportional to the frequency of the radiation, or E is directly proportional to V. According to Planck, radiation energy is expressed in the term of frequency as E equal to hv, where h is Planck constant with a number of 6.26 times 10 to the power of negative 34 joules. And the energy of photon can be calculated using E equal to h times c over lambda. Or the energy of quantization is having the equation of E equal to nhv.
Next, I'm going to talk about Einstein's explanation of photoelectric effect. First, let me give you an introduction of what photoelectric effect is. According to Einstein, light can be a particle called photon, which can hit electron in the metal and cause electron emission. And this phenomenon is called the photoelectric effect. He came to the conclusion that light are made up of wave packets called photons. Now, let's talk about Einstein's photoelectric effect. Electrons are held to the metal by attractive force of positive ion of metal, so it must possess enough energy to overcome the force. And when it does, photons strike an electron in an atom of the metal and transfer its energy to electron, causing electron to eject. So after taking Planck theory into account, Einstein resolved this problem using the idea that light was a particle. The energy carried by each photon depends on the light frequency. From Planck's formula, E equals h times nu. We know that the energy of the photon is directly proportional to the frequency of light. The minimum frequency that provides enough energy to release electrons from the surface of the metal is called the threshold frequency. A portion of energy is used to free electrons from the metal surface, and the remainder is given to the ejected electron as a kinetic energy. During the collision, electrons that emit from beneath the metal surface lose some kinetic energy. However, the surface electron that has the highest kinetic energy carry all the photon energy. As Einstein predicted that photon would pass through the material and transfer its energy to an electron, the kinetic energy is reduced by the work function. As electron passes through the metal at high speed, this reasoning led Einstein to develop the photoelectric equation HF equals work function plus EK, where EK is the maximum kinetic energy of electron.
And next is a key concept idea or basis that can be found in theory of quantum mechanics, which is wave-particle duality. So wave-particle duality states that light and matter can be both waves and particle properties because they are observed to behave like both wave and particle. This concept combined from the idea of Planck that talk about light is a particle and Einstein that talk about light is a wave. So this idea or concept can help physicists to understand many behavior of electrons. And next is Werner Heisenberg. So Werner Heisenberg was established the theory of uncertainty principle of quantum. This principle states that the particle's position and momentum cannot be measured with arbitrarily high accuracy at the same time. Furthermore, the product of these two measurements also exists in a minimum value. Therefore, there is a minimum value for the product of energy and time uncertainties. So, uncertainty principle formula states that change in x times change in p is more than or equal to h over 4 pi, where h is Planck constant, change in p is uncertainty in momentum, and change in x is uncertainty in position.
So the next topic is Bohr's theory of hydrogen atoms. Bohr model of the hydrogen atom is considered one of the most important in the history of science. The model holds a unique place in physics since it introduced an early quantum theory. It sparked new scientific thought and eventually led to the development of quantum mechanics. White light travels through a glass vase containing a Chilly gas and its wavelengths are separated using a prism. Some wavelengths in the spectrum of the passing light are missing, result in back absorption lines in the continuous spectrum on the viewing screen. Only certain wavelengths are present in the emit light spectrum which may be observed, as you can see in the picture. The atomic hydrogen emission spectrum. The spectral position of the emission line are unique to hydrogen atoms. The atomic ion emission spectrum. The spectral location of the emission line are unique to ion atom, as you can see in the picture. So Bohr model formula, there is two formula, Balmer formula and Rydberg formula.
Next, I'm gonna talk about electron behavior. In 1913, Bohr proposed that electrons could only have the certain motions. First, electrons that are located in an atom must orbit the nucleus. Second, electrons can only orbit stably in certain orbits, also called stationary orbits, at discrete distance from the nucleus. And these orbits are associated with definite energy called energy shell or energy levels. Third, by jumping from one orbit to another, electrons can gain or lose energy, and this energy difference can be determined by the Planck relation. So according to Bohr, Bohr model of hydrogen is based on electrons traveling in specific shell around the nucleus, and the specific energy in the electron shell can be calculated by the formula En equals minus RH times 1 over n squared, where n is the principal quantum number and RH is the Rydberg constant, which is equal to 2.18 times 10 to the power of 18. Now, let's talk about the ground and excited state. The ground state is the state of an atom having the least energy of all the possible value, while excited state is the state of an electron that is higher in energy than the ground state. When the electron drops down to a lower energy level, it releases energy. On the other hand, when jumping to a higher energy level, it absorbs energy. And the photon energy in different levels can be calculated by the formula delta E equal RH times 1 over Ni squared minus 1 over Nf squared, where R is the Rydberg constant, and F is the final energy level, and Ni is the initial energy level. Next, let's talk about degenerate. The term degenerate simply refers to the fact that there are multiple quantum states with the same defined energy. For example, an electron can be in one state rotating one way around the nucleus and another state rotating the opposite way in the same energy level. Next, let's talk about photons. Photons are like quantum particles that carry electromagnetic radiation, and its original concept is explained by Einstein's photoelectric effect. He described that light is made up of a small energy packet known as photons. It also has wave-like properties. So the total energy of an electron in the n orbit of a hydrogen atom is given by the formula En equal minus 13.6 eV over n squared, where eV stands for electron volt, which is the unit of energy. Next, the Lyman and the Balmer series. They are special line series derived from hydrogen emission spectra. The key difference on these two is that the Lyman series forms when an excited electron reaches the principal quantum number 1 energy level, whereas the Balmer series forms when an excited electron reaches the principal quantum number 2 energy level. So Bohr changed his model view of electron motion to match the spectral series of light emitted by real hydrogen atom. He proposed that light emitted from hydrogen atom only when an electron moves from an outer to inner orbit, and the energy lost by the electron during the transition is the same as the emitted energy of light quantum.
Next, we will talk about application, which is magnetic resonance imaging, which is also called MRI. It is a non-invasive imaging technology that creates three-dimensional detailed anatomical images. MRI is working by using technology to detect the change in rotational axis of proton in the living tissue. It is a technology of visualizing tissue that uses the physical phenomenon of nuclear magnetic resonance, which is the reunion of quantum with classical electrodynamics. It produces high-resolution image by using the quantum mechanical property of hydrogen atom, which help with medical diagnoses such as cancer, heart and vascular disease, and muscular and bone abnormality.